Welcome to 7.1 Notes. This is finding missing sides using trigonometry. Alright, this is 7.1 Notes, finding missing sides using trigonometry. Trigonometry functions like sine, cosine, tangent, you basically use these either to find a side of the triangle, or you can use the inverse of these guys to find the angle. So that gives you an idea of why we're doing this in the first place. But first, let's talk about some simple things that we can do with these. So if I have angle B right here as just x, first I have to talk about the parts of the triangle if I'm trying to find x right here. So I've got angle B, and notice the side opposite angle B. And when I'm saying opposite, that just means on the other side of the triangle here. We're just going to label that side opposite. Alright? Opposite. And the other leg of my right triangle, this is the side that actually touches the angle right here, is called adjacent. And finally, the side that always has the same name is the hypotenuse. Alright, so the hypotenuse is always going to stay the same, but the opposite side and the adjacent side just really depend on which angle you're looking at. Right here we're looking at B, but if we take a look at angle A right here, then our perspective kind of shifts. So angle A is this guy right here. This is the corner of this triangle. That's the angle. Let's look at what is opposite the corner of the triangle. The side on the other side of the triangle is BC, and now that's the opposite side. And the side that touches this angle now is the adjacent side. So now AC is the adjacent side. And finally, the one that always has the same name is still the hypotenuse. Okay, so why do we need to name these sides in the first place? Well, it's really important for our trigonometry functions. Now here I have Chief SOHCAHTOA, alright? And SOHCAHTOA is going to help us remember what our trigonometric functions are. So the first thing we have is sine. And if you'll just write this down, sine of x is going to equal, that's where our O comes in, opposite, over, and then our H right here, hypotenuse. Okay. And go ahead and write this down, and then as we work one of these problems, you'll see how we can use this. We have our ca, our C, so that's our cosine. Cosine of x equals, and then A, that's adjacent, over our H, which is hypotenuse. And last but not least, we've got our tangent. Tangent of x equals, so T for tangent, O for opposite, so opposite over adjacent. And you'll notice when I'm talking about opposite and hypotenuse that my opposite in sine equals opposite over hypotenuse just refers to the side of the triangle that I had up here when we were first naming these sides, right? And hypotenuse is always going to be the same one. Remember, guys, that hypotenuse is the longest side of the triangle. It's a side that's opposite of the right angle. And then we've got the adjacent side. Remember, that's the side that touches the angle here. All right. Now, let me tell you that in 7.1, that's this lesson here, if you have these three things, if you know these three things, then you are going to be good to go, because that's basically what this lesson is about. Now we're just going to look how to identify or how to use these three things. Okay, so when using your calculator, you need to make sure the mode is in degree. And if you have your calculator out in front of you, just press the mode button that is up near the top of the calculator, and you're going to see a whole big list of things. But one of those things is going to say radians. Here, that was horrible. Let me erase that and start over. It's going to say radians on one side, and then it's going to say degrees on the other. In all likelihood, that radians is highlighted right now. Well, just cursor on over to that radians, and then go over to degrees, highlight the degrees, and press enter, because we're going to be working with degrees here. Alright, so here's a calculator check right here to see if it actually is in degrees. If you take the sine, and that's just a little button, it's on the calculator, it says sine right there. If you click sine and then you click 46 and then press enter, if you get 0.719, then your things are in degrees. But if you don't, excuse me, then you're going to have to go back to that mode button and hit degrees again. Okay. Use a triangle to write the ratio fraction for the following. We're going to go through this pretty quickly. Remember, we've got so, ka, toa, and I'm going to refer back to that there. So sine, that's going to be our S, is going to be opposite over hypotenuse. If I'm doing sine of angle A, that's where I start from. So here's my angle A right here, right? And sine is opposite. So what is opposite my angle A? That is 2.5. 2.5 over hypotenuse, right? And the hypotenuse is always the same. It's on a triangle. It's just the side that is longest. It's the side opposite the 90 degrees. 2.5 over 6.5. Okay? Now, what if I take the cosine of A? I start with my angle, A. I'm going to trace that angle again. And this time, cosine equals adjacent over hypotenuse. Alright, well, let's see what the adjacent side of my triangle is if I'm looking at it from angle A. The side that touches angle A, that's the adjacent side, is 6. And my hypotenuse, it's always the same, 6.5. I'm going to jump over to 4 here. 4 looks at the triangle from angle B, the sine of angle B. So, angle B, I'm going to trace my angle B right here, that's my angle B. And remember that sine is just opposite over hypotenuse, and so I find the opposite side to angle B. The opposite side is 6. So that's 6 over, and then opposite over hypotenuse. My hypotenuse is always the same. That's 6.5. Remember, hypotenuse is always the longest side. It's the side that's opposite the 90 degrees. Now notice that both cosine of angle A and sine of angle B are the same ratio. And you'll always have that. If you're looking at the two angles A and B, remember we're not ever going to be looking at the right angle. We're always going to be looking at the two other angles, okay? So if you're looking at A, the sine of A is going to be equal to the cosine of B and vice versa. Okay. Take a look at the next page. I'll go ahead and do number 5 for you, and then I want you guys to work on the rest here. So remember, we always start with the angle, where the angle is. And I notice that they're asking me for two things. Well, first of all, they're asking me for x of the opposite side, right? And then they're giving me my adjacent side. Remember, the side that touches the angle is the adjacent side, right? So I've got A and I've got O. So I'm looking at the TOA part of my SOHCAHTOA. Why? Because I've got O and I've got A right here. And TOA is the only one that deals with both O and A. So what does the T stand for? It stands for tangent. So I'm going to say the tangent of my angle, which is 47. So it looks like this. Tangent of 47 equals my opposite side, right? And my opposite side is x, over my adjacent side. My adjacent side is 5. And then after that, I just cross multiply. So I've set up my equation, now I just cross multiply. Well, the tangent of 47 is the same as tangent of 47 over 1. That's just a different way to write it. It's the same thing. So now we're going to cross multiply. We've got 5 times the tangent of 47 and 1 times x. Well, what's 1 times x? X, right? And 5 times the tangent of 47 is just 5 times the tangent of 47. Okay, so now you're going to enter that into your calculator, 5 times the tangent of 47, and I'll pause for a little bit while you do that. Alright, so if you enter 5 times the tangent of 47 into your calculator, you're going to get x equals 5.36. Okay, so this is your x, and so that side is going to be 5.36 units long. Right? Now that's what sine, cosine, tangent, all these trig functions are good for. If you're given an angle and a side, then you can figure out the other sides. Alright, so finally I'm going to go and do one of these word problems just so we have an idea of how to do those word problems. And then I'm just going to let you finish the rest of these notes on your own. What is the height of a tower if point P is on the ground? Alright, so first of all, let's draw this tower. Okay, there's my tower. Got little lights on in the tower there. Alright. What is the height of the tower? Well, if they're asking me what is the height of a tower, the height of the tower is my x, right? Because they're asking me what that is, so that's my x, that's my unknown. if point P is on the ground 120 feet from the base of the tower. So here's point P, and point P is on the ground, and it's 120 feet from the base of the tower. And the measure of the angle from the ground to the top of the tower, now here's the ground, right? The ground to the top of the tower is 75 degrees. So this corner of my tower here, this corner of my triangle is 75 degrees, right? And I'm being asked to find the side opposite of my angle. So I've got opposite, and then this 120 foot side here is adjacent. This side is adjacent, so that's going to be adjacent. So I have O and A. Well, remember what my O and A is. It's my TOA. Tangent equals opposite over adjacent. So tangent 75 equals my opposite, which is x, over adjacent, which is 120 feet. And then I just cross multiply. Well, remember, tangent of 75 is the same as tangent of 75 over 1. That's just a different way of writing it. I cross multiply 120 times tangent of 75, 1 times x, and so I get x equals 120 times the tangent of 75. And go ahead and enter that into your calculator, and pause the video while you enter that in and get a number. Okay, so the number you should have gotten is x equals 447.8, and let's round up to 5 feet. So how tall is the tower? What is the height of the tower? It is 447.85 feet. Okay, so I'll let you do number 8 here, and then that's it. If you have any questions, just please ask during tutorials, come in during advisory, and look forward to seeing you there. All right.